Okay, so what I mean by a high performance cycloidal drive is that both the output and the input shaft is supported on both sides by a ball bearing. For example, here, this ball bearing supports the output shaft, and this ball bearing here supports this inner shaft. On this side, it's the same thing. This ball bearing supports this output shaft, but I've actually hidden the input shaft ball bearing on the inside of this, which I feel gives a cleaner look. So let's do a show all body. Oh my gosh, I misclicked. Show all bodies, and this is what it looks like. And we're going to be going on to design Cycloidal version 2. First, go to this GitHub, go to code, download zip. Once you download the zip, extract it in your downloads folder. Once you've extracted it, click on it. This right here, you need to drag this to this directory. So you can take this, copy it, paste it, enter, and drag. Why is it not popping up? Okay, there it is. Drag this in here, which I've already done, so I don't need to. So once you go to Fusion, you can go to add-ons, add-ins, whatever. If you don't see it, click this, add script from device. If you see it, click run. For this, for version 2, I'm going to slightly step down from the reduction ratio. In version 1, I did, oh my goodness, man. Add-ins, scripts and add-ins. Yeah, apparently if you click over to another one, it completely it just does it and you can't really edit it again, so it's kind of annoying. But okay, so for the version 1, I did 40 reduction ratio. I think I'm going to do 33, or I mean 35. The eccentric amount, this amount basically is how well it'll mesh with the outer pins. The higher this number is, the more torque bearing your system potentially could have. But too high, and it'll have a lot of friction, and you'll lose efficiency due to friction. So, but for a high reduction ratio, this number, you can't even have it that high, because if you have it too high, it's not possible to generate. So I typically use as high as the eccentric amount as I can for a high reduction ratio. Why is this reduction? Anyways, so since I have a 35 reduction ratio, I set this to 0.76, which is around the highest you can get with this pin pitch diameter thing. This is basically the diameter of your disc. I have mine to 60. I feel like that's pretty good because I want it to be pretty small. So 60 would actually, can we do it maybe like 55 or 50? Yeah, let's do a 55 so we can make everything a little bit smaller. Because I also want to put a gasket. You can see here when this number is too high, you can't even click OK because it literally it's impossible to generate. So let's try 3, 2, 1. Okay, so we can just do 0.7 eccentric amount. The ring pin diameter, I'm using this, which is a 3mm. So I put that as 3. Cycloidal. Okay, so the higher this number is, the longer it'll take to generate. But the cleaner, the more better the curves are, the more these little points there will be. So you can generally put it up to 8. 6 is fine for now. I mean, it doesn't really matter. The diameter of the center hole, I'm using a 15 by 21 by 4. So for my center hole, I will be using 21, which is the outer diameter of the ball bearings I will be using, because they'll be press fit into the center. So it'll be 21. Let's do a test view. Whole number. Okay, so basically the higher this number is, the more load bearing. I mean, the more torque you could potentially have. But you technically don't need too much. Usually the ones I see has 5, but going up all the way past 10 is probably more ideal if it's something you're going to be abusing a lot. So yeah, we can see also, let me look here. Okay, so this is a 5 by 9 by 3. These ball bearings is the output shaft. these will be supporting the output shaft, and I'll be fitting this on here because this is a 5 millimeter outer diameter. 5 millimeter outer diameter, so it's gonna be able to. This is gonna be able to press fit on there. I hope. If not, I gotta put it in the fridge or something. Maybe I don't know. Anyways, so what is this? This is a 5 by. Where is it? Okay, a 5 by 9 by 3. So basically, the diameter of these green pins right here, the output disc pins. Output disc pins. So I want to put set about output disc pins, and the pin number. I think 8 is a good place for me. I did 9 and it's overly excessive in my opinion for version 1, and you need a lot of ball bearings and don't have that much. Wait, actually, pause. I only bought a pack of 10, so I guess we can only do 5 technically. Oh my goodness, or I could just buy more. Let's see here. I mean 5 should work fine with the output shaft. Probably want to do a little bit more than 5. I think I'm gonna stick with 8. So it'd be 2 on top, 2 on side, 2 on this side, 2 on the bottom. I feel like that'd be the best. So I'm gonna stick with 8. I'll just buy more ball bearings later. Okay, so the pin diameter. Hey, what is the pin diameter? Oh yeah, sorry. This is the green, the diameter of the green, which is gonna be 9, which I said earlier. Center to pin. Okay, so let's see the test view here. Why is it taking so long? Okay, so we can see that this is a little bit too far out, so we need to bring this in a little bit. So maybe like 36. Dang, I only bought 10, and we need. So okay, if we have say 5 of these, then we'll need 10 because there's going to be 2 cycloidal discs. That looks pretty centered, I would say. That looks pretty good. I think we can go with this design here. Oh yeah, and going above A won't work because they're way too close together. Maybe 8 is too much. Loki want to do even number because it looks cooler in my opinion. I don't know. Let me think here. Okay, 8 should be fine. Might be a little excessive. Yeah, it probably is a little excessive. But I mean, eventually what I could do is replace a cycloidal disc with metal, with like laser cut. I mean, not laser cut. Water jet or CNC. Probably water jet because it's cheaper. I don't know. Unless I can get somebody to sponsor me. But yeah, this looks pretty good. Okay, let's just check over everything. Yeah, it looks good. Okay, now click OK and it'll create the sketch. Countersunk screws, brushless motor. I'm using a 5010, 360 kV. There's supposed to be high torque, but 360 kV, it's not as high as I would like. That's why we're doing such a high reduction ratio. Hopefully it's backdriveable. We just need to design this in a way that's good. So for this disc, I'm using 4 because where my ball bearings, where are my ball bearings? These are by 3 millimeter height, so I'm going to do a little bit over the 3 so it meshes properly. I'm going to do 4 here and click this entire thing and deselect all of this and do. Okay, let's see here. These pins are 16 millimeters, so we can do. Let's do 10 for now and do a new body. And these ones here, we can just do new body too. So this is what a cycloidal disc looks like. We need to add some clearance. So basically, for version 1, I didn't use any scarf seams, so that's kind of bad. So version 2, I definitely need to use scarf seams and a 0.4 millimeter nozzle or less, and a lower layer height to make it more accurate. So let's see here. Yeah, we definitely need to get rid of all these. There's a lot. So let's add some clearances. If we can go here, create sketch, do offset, -0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1. 0.1 Click extrude. Get rid of that. Why is this geometry? What in the heck is this geometry? Why is it? Yo, what is up with this geometry? What happened? I'm so confused. Huh? Okay, I'm gonna isolate this. I don't know what's... Why is everything selected? I'm so confused. Yeah, I think my computer's tripping, my Fusion is tripping, but... Here, I'm gonna click save. Okay, go here, close out of this, and open it up again. Yeah, I have no idea what is happening. Okay, it's fine now. Isolate. Create sketch. Offset. -0.1. Add. Yo, why is it doing that? It's never happened before. Okay, that's really strange. Well, anyways. Okay, show all bodies. Okay, great, now we have clearances. So we need to add another second cycloidal disk. As you probably know, or else it's going to vibrate, and we don't want that because it is going to be running at a pretty high RPM. So what we can do is find this, call this cycloidal 1, cyc1. Do copy paste. Move it up so it has around 1 millimeter space between. Click OK. And now we have one disk on top of the other, which is not what we want because they need to be out of phase by 180 degrees. So this one will be on the bottom. Let's name this cyc2. Okay, now we can do a copy. Wait, no, not a copy. What am I doing? Do a move and sets the pivot in the center. And it doesn't set because it's being stupid. Okay, so what we have to do here is do a sketch here. -1, do a new body. It won't set it because there's not a body for it to set on. Now it should work, hopefully. Pivot set in the middle. Let's do top view. There we go. Click OK. Now we need to move it so we can see here that it's meshed on this side perfectly. So we need to move it this side. Let's get rid of this. And this way by your eccentricity, which is, look, you don't know. So what we can do is go to utilities, go to add-ins, cycloidal, where's cycloidal? Right, there it is. So 0.7, okay. So move, set pivot in the middle, click OK. Move this side by your eccentricity, which is -0.7 times 2. If you don't do this, it won't mesh properly. And now you'll notice that it doesn't line up now. So you need to rotate this by a degree that is 180 divided by your reduction ratio. I did 35. There we go. Now we can see it lines up perfectly. You can click OK. And now we can see that these holes do not mesh properly. So what you need to do is do another sketch. Here, draw a thing that's slightly above this. Usually what I'm going to do is do isolate. What? Isolate this one. My bad. There we go. Now, get rid of the sketch. solid, create sketch, make a circle that's slightly above this, take this, extrude it all the way through, cut it, I mean. Now you can go back to your sketches. -4, and do a new body. So now you have this, and what you need to do is, since you rotated this by 180 divided by your reduction ratio, you can just rotate this part back, which is pretty funny. So you can do a move, set pivot to the center, which isn't setting for some reason. Okay, let's do this. Let's do a create sketch. Actually, we don't need to do this, actually. We can bring back everything so we don't have to make a new body. Where is it? Show all bodies, there we go. And we can close that sketch because it's in the way. There we go, okay. Now that we have this, we can do a, for the cycloidal too, no, for body, nope. This one right here. Do a move, set pivot to the middle. Yeah, and it's setting to the middle of that, which is quite annoying. Okay, let's just do this then. -2, new body, there we go. Move, and then we can put this pivot in the middle. Okay, and now we can move this in the opposite direction, -180 divided by 35. There, boom. Now it matches up perfectly. Now we can get rid of this. This is body 49, we can delete this, we don't need this anymore. We also don't need this anymore. Delete this. Okay, there we go. I don't know why I deleted those, because we still need them technically in a bit. Now you can do combine these two. Boom, perfect. Now we have exactly two cycloidal discs, 180 degrees out of phase with each other. Looks like a pretty nice design so far. Now comes the hard parts. Now we need to create these supports. Okay, so let's see here. These are 5mm outer diameters. Okay, let's see how I want to do this. Let's get rid of this. Create sketch here. Project. Five. Can we do a circular tool? About this. How many do we need? 8, right? There we go. Oh wait, no. This. Select everything. Extrude. Click OK. Yo, what is that? Bro. Bro, why is it not extrude? What? Yeah, what is wrong with this? Yeah, I'm so confused. What? Okay, there we go, finally. Anyways, alright, so... Okay, where are my cycloidal discs? Cycloidal disc, cycloidal 1. Yo, where's my cycloidal disc 2? Hello? Dude, am I tripping? Show all bodies. Yeah, where is this? Yo, why is this not named cycloidal 2? What happened to it? Whatever. Oh yeah, because whenever I combined it, I clicked the wrong one. Oh my goodness, I'm so stupid. Okay, anyways. Okay, so we can see here that we have a 1 millimeter distance, probably. I don't know. Yeah, we have a 1 millimeter distance, so let's create another 1 millimeter distance above this. Inspect this to this. It's 4 millimeters, so do is boom, boom, boom. Wait, pause. Before we do this, I need to check something. This is a 10 millimeter, okay. So from here to here is what? Distance of 9 millimeters? Oh shit, I'm cooked. Those might be too short. Oh my gosh, I'm cooked. I'm cooked. I'm cooked. I'm cooked. Okay. How can we go about to fix this? So apparently, 10 millimeters is too short. Okay, M3 metal threaded standoff spacer nuts. Ten millimeters. 12 millimeters. Please, come on. Okay, they do have 12 millimeter ones. I guess I could just buy that instead. Okay, let's see here. If this is 9 millimeters. Oh my gosh, this is quite annoying. Should we do, let's see here. 12 millimeters or 50? We should probably do 15. Okay, so 15. 15 minus 9 is 6, so we can have 3 poking on each side. Yeah, let's do 15. That's so expensive, bro. Oh my god. $11. Oh well, I'm sure we can buy that. So we're gonna be using these instead, actually. 15 millimeters. Is it still 5? Okay, yeah, it's good. Okay, so we can have 15 minus 9. 6 divided by 2 is just 3. So we'll have 3 sticking out each side. Okay. So let's go like this. And do a -1. So now this side's sticking out by 3. There we go. And let's do 3 on this side. That'll make up 15. Okay, there we go. You know what? I'm gonna go ahead and try to see if I can refund the other products and buy this instead. But I don't want the coating, low key. Oh well, I'm sure it'll be fine. Actually, it doesn't really matter that much because I'll put a ball bearing on it. So it's technically not rubbing against anything, so it's okay. I don't think it's shipped yet, right? It hasn't shipped, okay. Cancel items. You know, this is all part of the process. Okay, canceled it. M3 round threaded spacer. Are those like powder coated or what are they? Why is it? M3 metal threaded standoff spacer nuts. Okay, I'll buy that later. Anyways, get back with this. So we need, let's see here. this, 1 millimeter. Okay, so let's do create sketch here, just so it's convenient. From the center, I guess we can go all the way out here. Maybe we should do a little bit more. Let's see. Solid measure 2.3. Yeah, we should probably do a little bit more. Need to make sure there's enough room. Let's do 48. Should be good. New body. This will be the output shaft. If we made this 3, would that be good? Let me think here. We can just do 3 for now. What do I have for this one? 5.5, okay. So we probably need to do a little bit more. 5 is probably good, more than enough. Okay. So let's take this body, copy paste. Actually, we don't need to. Both sides will be the same. So what we can do is just make one side and then copy it on the other side later. Combine. So we need to keep this piece. Get rid of this, rid of this, rid of this, rid of this, rid of this. This one, this one, this one. Click OK. And now we have mounting holes. And okay, now let's get rid of this, get rid of this. Why is that there? Hello? Why did it? Oh, it created another one. Oh, we don't need this one. Okay, delete. Okay, now that we have a way to mount this, mount the standoffs onto this, 3 millimeters, and then we have a M3. So we need to screw an M3 in there, which we'll use countersunk like this. And this should be 2 millimeters, right? Distance is 2. So we have 3 millimeters of less of space, which is probably good, right? I don't know, we'll see. Let's do a sketch. And M3 bolts are typically 2.8 millimeters, so we can do 2.9. They're not a full 3 millimeters, and I want it as tight as possible. So this should. Okay, wait, pause. I should probably make this slightly bigger so that the rods actually fit. Yeah, let's do that. Okay, so can we do? What can we do here? Can we just do a create sketch? Can we just offset everything? What's the fastest way to do it? It's probably just this way. So this is 5. Let's do a 5.1. Now let's go through the painful process of selecting every singular one. Is there a better way to do this? I don't know. Don't care. Actually, I do care. I want to learn. This is annoying to do. And if I accidentally click a wrong one, it's gonna have to start over. Good thing there's only 8 and not like 20. Okay, now we can extrude this all the way through. No, wait, not all the way through. Just by 2, right? Yeah, -2. Great sketch. Now we need to do, what was it? What did I say was 2.9? And we can drill it if we need to make it more, to make it bigger. So for now, let's just go like this. This be 8. Okay, this is easier to select, which is good. Low-key not sure how to make this countersunk. Is there any dimensions for this? Come on, bro. Why is there no dimensions? Okay, M3 countersunk screw. They're probably all pretty standard size, I would say. Great, can't find any dimensions. Probably just look on Google. Wait, perhaps? Great. M3 counter sunk screws. Dimensions. This is 90 degrees. Okay, so let's see here. DK, we need DK. For M3, it's 5.2. Does that seem right? I do have an M3 screw bolt nut into 5.2. So I guess a 5.2 is correct. Okay. Create sketch. So we need to make the countersunk. Actually, no, what am I doing? Delete this. So we can just do a chamfer here. Oh, we could just technically make it bigger than it actually needs to be, and then it would work. What is this? Diameter 4.9. Okay, so we need to do a little bit more. So like 1.3. 5.5. Okay, that's good. So 1.3 on all of these. Chamfer 1.3. Perfect. We have a 1.7. Ooh, that's might not be good. 1.7 is quite low. Yeah, I'm sure it'll work. We can extrude this by 0.5. Yeah, this will work. Okay, now let's create the hole for the support for this, which will have an inner diameter of 30. Wait, let's just to see 37. Okay, so this is where the ball bearing is gonna sit. It's gonna sit on top of the screw, which is unfortunate, but for space saving, this is what we have to do. And this would be up by, let's do a 5. Actually, let's just do 4 right now because it is a, I don't know, let's just do 5. What am I doing? This might be a problem because I actually need to put a little ledge on here. Okay, let's do, put up by 1. I mean, this works, I guess. Okay, there we go. Because so we can set the ball bearing on here without it rubbing against all the other stuff and being annoying. And the center of this is going to have a 21 because that's the outer diameter of the ball bearing. How far down does it need to go? 10.5. Okay, there we go. Both sides will be symmetrical right now, so let's take this. Let's do output top, and we can do a move and then flip this 180. Wait, what am I doing? Do a copy paste. Can move this 180. Make sure everything lines up. Okay, now it lines up. Bring it down. 31.5 maybe. Okay, no, 32. That looks good enough. Check here to here should be at 0.5. Okay, it is 0.5. This is perfect. This is what my cycloidal drive looks like, and it looks amazing. And it's beautiful and amazing. Alright. So this will be around the overall... Oh, 31. That's quite long. Okay, show all bodies. This is 30. Okay, it's fine. It's fine. It's fine. It's 1 millimeter more. I'm sure it's fine. This and this should be... Why is it doing that? It should have a distance of... Yeah, that looks flat to me. This bottom isn't flat though, which is quite annoying. Okay, let's see here. 1 millimeter. Okay, so how can we... Okay, maybe we don't need to do that. Okay, let's just go here. This is 16. This is 10. Wait, didn't I extrude this earlier? Let's just do 9. Yay, perfect. Okay. Let's make this invisible, invisible, invisible. Okay. Okay, let's do some calculations. If it's 16 and this is 9, 16 minus 9 is 7, divided by 2 is 3.5. So let's do 3.5. Okay, what is this, man? Okay, seriously, what is this? Why is this here? Why can't I make it go away? Okay, perfect. So extrude 3.5 on this side. Extrude. Why is extruding this way? Okay, let's just do negative 16 then. And do a join. Alright, perfect. Now we have our pins. Show all bodies. Wow, this looks amazing. Except for we might have a slight problem. Yeah, we actually might have a slight problem. We need to make this slightly shorter, actually. Because we need supports for these pins, so this is going to be a little bit too big. I mean, I'm sure that... Wait. How much millimeters is here? Wait, why is there... Wait, what is that? What is this? Why is there... Okay, what is this? Okay, this diameter is 5.1. This diameter is 5. Huh. Strange. This to this is... Wait, 3.5. That doesn't seem right. Wait. What did I say it was? Okay, so 15... 15 minus 9. Okay, I think it's right, actually. Huh. Does the other one have that too? Okay, when did I do this extrude? Was it here? Is it here? Oh, it was supposed to be -3, and I did -2. Okay. I'm so stupid. Alright, there we go. Fixed it. Easy. Alright. Show all bodies. Show all bodies. Okay. What am I doing now? Oh, yeah, making this. Wait, I should need to check something first. Remember now. This to this is 3.4. 5. -0.5. -1. Is that gonna be good? I hope it will be, right? Yeah, it should be plenty. Okay, now we have a lot of space to work on what we need to. Alright, so let's make this go away. Let's create a sketch here. Let's see, let's make... Okay, let's see here. Let's do 49, just so we have good clearance. We will have, how much clearance will we have? 1.5 millimeter clearance. Is that good enough? Yeah, I'm sure we get enough, right? Okay, maybe let's do 50. Should we do 50 though? Only 1 millimeter. Oh my god, this is a difficult decision, guys. I think 49 will do, guys. Okay, there we go. Oh wow, this is actually a lot smaller than the other one, I think. 60. Let's just do 60 for now. We can add on later. Let's first just start with making this even with this and do a new body. And let's check the height distance from here to here. This is 5. So from here to here, it'll be 4. And 37, which is the outer diameter of the ball bearing. -4. Do a join. Perfect. This seems pretty promising. Okay, let's take this cover and do a move Create copy. Flip 180. Move so it's over here. Move it up so it's flush with this part. There we go. And now we can just, okay, let's look at this. What is this? This is the output top. Okay, so the bottom will just go all the way up till it meets that, which is 8 millimeters. Join. Oh no, okay, not that. That was not a good idea. Okay, let's do. You know, it needs to be 8 millimeters. So we can go like this. Isolate. 8. Okay, now hide all or show all bodies. Wow, that looks awesome. All right. Pause. There's something wrong with this. There's something majorly wrong with this design. What is happening? Okay, so that could be a problem. Need to go back, go back, go back. Okay, yeah, okay. Can't do that, forgot. Create a sketch. No, not extrude. Come on, come on, come on, work, hurry up. Create a sketch. We need to do it so that it doesn't mesh with the teeth. Something like this should work. Okay, there we go. Finish sketch. Okay, now we can go to body. Okay, what is this? This is the hello lid. And we can isolate the body. Go back to the sketches. Eight. Okay, now bring in the lid. Okay, wait, no, no, no. What am I doing? Go to show all. Now we can get rid of this, get rid of this, get rid of this. Now we just have this stuff. And now we can do a combine. Okay, so there is a problem here. There isn't a problem. There is a problem. Let's get rid of this for now. We can just do that part later. I'm sure there's a better way to do this, but I'm sure this will work too. Cut. Yeah, there's definitely a better way to do this. Goodness. Wait, can I just highlight it? Oh, I'm so stupid. I can just highlight it. Okay, keep tools. Yeah, wait, where'd it go? Oh, yay! Nice. Alright, now let's do the lid. Okay, what did we learn? We learned we can highlight it. Click OK. Perfect. Let's go back one. Go forward one. Let's do not keep tools. Perfect, chat. Perfect. Absolute perfection. Okay. So body, boom, boom, boom. Let's see what's the clearance. It should be 0.5. Wait, it's 1 millimeter? Why is it 1 millimeter? Oh, it is. Yeah, yeah, never mind. That's right. 1 millimeter here. Definitely need to add some clearance to this right here. Okay, now chat, how do we add clearance? I'm gonna check something. From here to here is 12. Create sketch. Maybe not like this. How do I add clearance? Can we do a create sketch here? And do an offset. Okay, so we can do 0.1. 0.1. Click OK. Okay, maybe not like this. Let's see here. How do we add clearance? Wait a minute. I have an idea. I have an idea. I have an idea. I have an idea. Maybe like this. Okay, maybe not like that either. What is the best way to add clearance? Maybe you can just manually do it. Alright. .2. Is that clearance too high? 3.15. Is there what other way is there? I can't think of one right now. I don't know what's happening. Okay, what am I? We can create a. Let's do a 2.2 clearance here, and just go down. So it's here. Oh, I'm so smart. Oh my gosh, I'm so smart. How did I figure this out? Okay, now we can do a clear. Okay, never mind. I'm not smart at all. So I have to do each one manually. Like, bro, come on. Is there really no way to, like, 3.1? Circular tool, center point, objects here. What is this? What did I do? Like, so this should be 36. Okay, nice. Oh my gosh, it worked. Okay, nice. Perfect. Now we have clearance. Now let's do the same thing to the lid. This should be a lot easier. Okay, let's do a 3.2 for the lid. Just so it'll be easier to put on the lid. I don't want to be over there struggling to put on the lid. 3.2, and then circular tool. Quantity will be 36 too, because my reduction ratio is 35, so this will have one more than the reduction ratio. Great. Is this -4? Yep, there we go. Wait, was it -4? It is 4, okay. Wait, why didn't it work? Hello? Question mark? Wait a second. What is happening here? .2, this seems right. Huh. Okay, there we go, that worked. Also want to add a fillet here so we can put the lid on. Because I really doubt without a fillet we'll be able to put the lid on. Maybe we can do a chamfer. Then we can delete this chamfer, we don't need that one. Delete this chamfer because we don't... Great, doesn't work. Oh my god. Make this a little bit bigger. Create sketch. Wait, what am I doing? Why am I creating a sketch? What am I doing? Wait, delete. Chamfer. 0.5. Perfect. Yay, come on. Delete this, delete this. Alright, there we go. Okay, let's do a chamfer in here too, so we can put the thing in. Like 0.5 maybe. Yo, why does it look like that? Oh, because the inner. Let's not do 0.5, let's do like 0.3. 0.2. 0.3. Okay, should work good enough. Alright, now we have a place for the pens to go. Place for the ball bearing. Everything is looking pretty nice. Okay, so Alp. Okay, let's do some measurements. Okay, why can I... What was that? Hey, what is this? Pause, there's something wrong with this. Why is this inside of that? Is it this? This? Huh. Why is this broken? When did this become like this? 29. Huh, that's so weird. It was 31 earlier. That's quite strange, I'm not gonna lie. Yeah. Okay. Don't know what happened there. Okay. Okay, there we go. Yeah, I have no idea what happened there. Huh. I hope everything still meshes together correctly. correctly. Now there's 0 millimeters, which is unfortunate. -1. 1. So we need to fix this entire thing somehow. 1. Okay, there we go. Fixed it. Easy. Okay, now from here to here should be 31. There we go. Alright, let's go on about the middle now. Okay, let's see here. So this distance, we need to create the input shaft now. 10.5. Negative 10.5. I forgot to click extrude. Stupid. New body. Click OK. Should be 4. There we go. Create sketch. -4. Oh no, I didn't do it correctly. New body. There we go. This should be -4 too. Create sketch. -4. Body. This should be 10.52 then. Okay, sketch. Extrude -10.5. New body. Okay, now we got our input shaft. How can we connect this? Okay, let's see here. We can make this go up by 0.5. We need to connect these middle two, so let's go with this by go up by 0.5. And this go down by 0.5. Okay. Let's raise this by 0.5. We're gonna raise this by 0.5. I feel like if we did this, the ball bearings would sit more snug. Okay, this should be good. Yeah, this is good. Could potentially even add a chamfer here. Would it? I don't think a chamfer would be good actually. Would it? Yeah, we can add a 1mm chamfer here. Let's see here. Just so this is to help with the printability. 1mm chamfer. 1. I feel like this could help with the printability with this piece. These middle two shafts can be conjoined. This top one and this bottom one can't be joined, so we need to have a system. Probably just screwing 2 M3 nuts all the way through it. Either that or for prototype 1, I did 4 M2 nuts, which is excessive in my opinion. Let's do 0.5. Just consider either bring this up 0.5 or this down 0.5. I'm not really sure. I think I'm gonna point this up 0.5. Cyc disk shaft lid. Okay, so this should be the shaft bottom, shaft top. Okay, let's see here. Yeah, I'm actually not sure how I can. I'm trying to think. Maybe we need something that's easily printable. Maybe we can do something like a small square. A 6 by 6 square. 5. Okay, so we can print this a line down like on this side right here. The square on top. Let's do 6.5 by 6.5 square. Let's do 6.3 by 6.3. -5. So -6, so I have a little bit of room. And then we'll add chamfers of, or fillets of 0.4. So let's add a chamfer instead of a fillet. Okay, so we can print this, we can print this. Now we gotta figure out this part right here. How can we attach this? I guess we could just do another square. Should probably make this square a little bit smaller, like a 5 by 5. Shrewd. Can make it go up by 5. This is 9, so it should be fine. Point 3. can add a fillet of 2. Maybe more than 2. Let's see here. Let's do 2.3. Create sketch. 5.2 by 5.2. Negative 6. Okay, and then we can do a fillet of 0.5. Chamfer would be better here, actually. Chamfer, chamfer, chamfer. 0.4. Okay. Fillet of point. Was that 1.4 or something? What did I have the fillet at? I'm kind of forgot. Oops. Hello? Wait, I can check this. No, not this. 2.3, okay. Okay, now it should fit. Now let's bring back everything. Show all bodies. Oh, wait a minute. I forgot to... So stupid. Oh no, this is not good. I forgot to add... The inner diameter is actually 15. Ooh, okay, that's not good. It's easily fixable, don't worry. Fifteen's the inner diameter of the it's 5. Okay, there's something wrong with this. Why is this 4 and why is this 5? Okay, let's do negative 1 here. Okay, let's just do this. 15. That's not even right shape. 15. Negative 4. 15. Negative 4. Alright, now I got a wobbly shape. A big ass wobbler. Great. Oh, this is a pain to deal with. Oh, this is a great big pain. Okay. Where did I combine these two? Yeah, where did I combine these two? Am I blind? Oh, I didn't combine them. I just extruded. Okay. I'll start deleting random stuff. I'm sure it'll work. Okay, maybe not that one. Alright, there we go. I can't believe I forgot to do such a simple thing. I think it's over for me, guys. Extrude. Oh my goodness, finally I fixed this annoying part. Okay, so 0.5. 0.5. Yay, let's go, finally. Just gonna go ahead and add a fillet of 1. Just do the trick. Wait, no, not a fillet of 1. What am I doing? Fill of 0.5. There we go, okay. Finally. Okay, now we see if I find a way to join all of them together. Why did I create a sketch? Okay, I think everything lines up now, finally. Now let's put 2 should I put 2 or 4? 2 or... Let me think here. Should I put 4 or 2 screws? Four and 2 is probably better in my opinion. Shaft top. Okay, so this is the top. Let's bring everything back. We're finally almost done. Let's see here. Bring it down by -2. Oh, I did buy a countersunk in 3 screws. That would actually work better, probably. Would it? No, it probably wouldn't. Actually, doesn't really matter. Let's go 10. And then... Yeah, 10 is probably too much. 8 is probably good. Okay, we can do a 1.9, 0.9, 0.9. Okay, and then we need the head of the bolt to be secured. Or I mean, not secured, to be sunk into the thing. Head of an M2 bolt is around 4 millimeters. Let's do 4.3. 4.3. Project. 4.3. Should probably use stainless steel instead of 304. I mean, 12.9. Because we're going to be putting grease and stuff in here. I don't want it to rust and everything. Wait, what did I do that? Okay. No, go up. Let's do 1.5, should be fine. Okay, so for the bottom. Okay, let's go look at the motor to see how we can connect this to the motor. So we can see that it doesn't provide mounting holes. So let's not worry about it. But yeah, this looks pretty much done, right? Those screws will screw all the way down. Out the bottom. Should probably add some threaded inserts in here, to be honest. Diameter 1.9. 2.8. 8. I want to bury this quite deep into the shaft, so this should be good. Yeah, this looks pretty good. We can add a slight fillet. So the heated insert will sit good. Nice. This looks pretty good. And then for the other holes, we can add more fillets here. Heated inserts. Or not, what am I talking about? Fillets. Threaded inserts in here. So, now let's see here. Wait. Show all bodies. Yeah, this looks pretty good. Now obviously we need mounting holes to mount everything together, so create sketch, polygon. I'm gonna do a like so. Okay, this is annoying me. Oh my god, okay. Another thing I really want to add to this design is a... let's see if I can do it actually. Make it 2. .8. Let's do one more. Okay, the diameter is 68. Let's compare this with this. This is 80? Oh my gosh, okay. Yeah, 68 is definitely fine. Okay. I was scared that I was gonna not have enough room. Okay, so here's 58. We did 61. If we did a offset by 2 millimeters, -1, we can print a TPU 3. This way we can print a TPU thing. Lid. Create sketch. 62 and then offsetted by 2, right? Wait, was it 62? It was not 62 then. It was 61, alright. Well, still offset 2. Perfect. Lid, body, So one, another one, that's going to be 2, so we can do a 3mm TPU. Create sketch. So 61, and then an offset of 1.5, and then we can do this to be 2.6. That'll essentially act as a O-ring. Okay, should be fine. I don't think we need to add anything else. Looks fine. Alright. Good. Now we can do the polygon. Script polygon. What is happening here? 1.5 join. Body. Create sketch. Polygon. Join. Lid. We can do that later. Right now we need to you know what? Thinking about it, since we have a gasket, probably shouldn't do 6. We should probably do 8. Yeah, that's probably a better idea. Yeah, let's do that just because we have a. Alright. I have another idea of what we can do. Instead, like this. And then polygon script. Oh, wait, oops. Script. 8. This will make the gasket stronger. 100%. Negative 11.5. Now get rid of this one. Add in the lid. Wait, no. I just did the lid. Add in the body. Go to sketches. Alright, nice. Okay, what is the 4? Okay, should we do M3 or M? Sketch. It at a 2.8mm. Okay, I think what we can do instead of this, because that's too tight of a tolerance, do something like this. .8. This is quite a pain. This is definitely quite a pain. We could just make it bigger, but I don't want it to be too much bigger. That's the thing, though. I'm sure this will be fine. Okay, no, it's not. It's not gonna be fine. I don't want it. I don't want to like make it like that. Okay, so let's go out to. Is that gonna be too thick? No, eventually we're gonna use metal for the inside, so I guess the thicker one would be fine. So 5. Create sketch. Polygon inscribe. 8. Lid. This should definitely work very well. Nice, finally, okay. Okay, now what am I doing? Create sketch. Wait, what? 78. 70 looks fine, right? Two 2.9, 2.8. Okay, now we need 1, 2, 3, 4, 5, 6, 7, 8 all around. Click OK. Before I click everything, let's add the body back. Okay, maybe no, let's not do that. Now can we have the body back? Extrude. Symmetric. Cut. Yeah, it looks nice, okay. Now let's click everything and add a chamfer. Hopefully I don't mess it up and have to start over. Okay, why is the entire thing blue? Well, like what, bro? Chamfer. Yay, worked. Oh my god, let's go. So happy. Okay. Chamfer of 2 looks fine enough. Good enough. Looks pretty good. Now we'll have this. Everything looks good. Okay. Let's see here. I feel like there's could be something we can improve with this part. Yeah, there definitely is, and I just thought of it. We want this to have a... 1 second. Okay, so let's see here. That's 10.5. So we can do a 6.5. Create sketch. 18 will work. 6.5. If we did this, or negative 6.5. This will prevent the bearing to go wobbly. Okay, this is good. Could add this to the other side too, but just not as much. Where's the output disk to? Or output disk top? Okay, so we want the ball bearing to... Is that a fillet of 1? Okay, maybe not, like 0.4. This to this is 2. We'll need a 4, so 6. And then from here to here is 10.5, so it's going to be 4.5. Okay. Create sketch. Wait a second. Do 18. Negative 4.5. Nice, okay. Actually not nice, because... Actually nice, this is good. Another thing we need to consider is this output shaft is right here, and we have a diameter only 4.5. Preferably this needs to be bigger to accommodate. Actually, no, it's okay. Because we can just use M2 threads. M2 isn't as strong as M3. But basically, that's the gist of it, and that's how you create one. This is a pretty high performance one. Add some threads here if you want. The input, add some more threaded inserts if you want. It doesn't really matter, but yeah, there we go.